Welcome back. In the clip presented on my YouTube channel at Alexandru, I will tell you about how tornado is formed, the stages of the formation of a tornado, types of tornadoes, duration of the tornado. Stay with me in the following minutes of this video clip to find out the details, steps, and examples that I will explain to you in this video clip available on my YouTube channel. Tornado formation is a fascinating and complex meteorological phenomenon involving a number of atmospheric processes. Tornadoes are violent whirlwinds of air that can cause major damage when they make contact with the ground. They are usually associated with severe thunderstorms and are common in certain parts of the world, such as the United States, in the area known as Tornado Alley. In this article, we will analyze in detail how a tornado forms, what are the necessary conditions, and what types of meteorological phenomena contribute to its development. 1. What is a tornado? A tornado is defined as an extremely violent vortex of air in contact with the Earth's surface and which is connected to a cumulonimbus cloud base or, in rarer cases, a cumuliform cloud. Tornadoes can vary in size and intensity, but all have a rapid rotational motion, which gives them their destructive power. The wind speed inside a tornado can vary from a few tens of kilometers per hour to over 400 kilometers per hour. Tornadoes can last from a few seconds to several hours and can cover a distance of several meters to tens of kilometers. 2 conditions necessary for the formation of a tornado. In order for a tornado to form, some specific atmospheric conditions are necessary. These are most commonly seen during supercell storms, but can also occur in other, less severe storm types. A. Atmospheric instability. One of the key factors for the formation of tornadoes is atmospheric instability. This occurs when warm, moist ground air is covered by a layer of cooler air, forming a temperature and density contrast. Under such conditions, warm air begins to rise, creating strong updrafts. These updrafts are essential for the development of storms and, by extension, tornadoes. B. Wind shear. Wind shear is another essential factor in the formation of tornadoes. This refers to changes in wind direction and speed at different altitudes in the atmosphere. When the wind at high altitude blows in a different direction from the wind on the ground, a horizontal air rotation effect is created. This effect can be amplified by updrafts that lift this rotating air into a vertical position, forming a mesocyclone, a rotating column of air inside the storm. Although not all mesocyclones lead to tornado formation, they are essential to the process. C. Humidity. Moisture also plays a crucial role in the development of tornadoes. The warm, moist air at ground level provides the energy needed for updrafts. The more humid the air, the more energy can be released during the convection process, which can intensify the storm. D. Atmospheric fronts and air convergence. Tornadoes often form in association with atmospheric fronts, the transition zones between warm and cold air masses. A cold front can push warm, moist air aloft, creating an area of instability. Air convergence, that is, when air currents from different directions meet and push upward, is another favorable condition for the development of a tornado. 3. The stages of the formation of a tornado. The formation of a tornado involves several stages, from the initial development of the storm to the final dissipation of the phenomenon. A. Development of the storm. The first step in the formation of a tornado is the development of a strong storm, usually of the supercell type. A supercell is a special type of storm that has a well-defined mesocyclone, a rotating area inside the storm. These storms are often associated with large hail, torrential rain, and frequent lightning. As the storm develops, updrafts carry warm, moist air aloft and cooler air descends around the storm. Wind shear helps to form a rotation within the storm, which can lead to the formation of a mesocyclone. B. Formation of the mesocyclone. Inside the supercell, the updrafts and downdrafts interact, and the mesocyclone begins to form. This rotating column of air can be several kilometers in diameter and is a critical step in the formation of a tornado. As the mesocyclone intensifies, the updrafts become stronger and the rotation becomes increasingly rapid. However, not all storms that develop into a mesocyclone lead to the formation of a tornado. Additional atmospheric conditions are required for the rotation to reach ground level. C. Air thrombus occurrence. If conditions are favorable, the mesocyclone will expand downward, forming what is called an air plume. This stage represents a visible column of rotating air, but which has not yet touched the ground. The air spout becomes a tornado the moment it reaches the ground and starts causing destruction. To needless point, the wind inside the tornado can be extremely strong, causing significant damage in its path. 4 types of tornadoes. Tornadoes can be classified according to their size and intensity. The most common classifications are based on the enhanced Fujita F scale, which measures wind speed and the degree of damage a tornado can cause. A. Weak tornadoes. These include tornadoes classified as F0 and F1, with wind speeds between 105 and 177 km per hour. These tornadoes cause minor damage such as partially torn roofs and uprooted trees. B. Moderate tornadoes. F2 and F3 tornadoes have wind speeds between 178 and 322 km per hour and can cause considerable destruction. Well-constructed buildings can be severely damaged and cars can be overturned. C. Strong tornadoes. The strongest tornadoes, classified as F4 and F5, have wind speeds in excess of 200 miles per hour. They can cause catastrophic damage, completely destroying houses and lifting large cars into the air. F5 tornadoes are extremely rare, but when they do occur, the damage is immense. 5. Development and duration of the tornado. The tornado goes through several phases during its life. After the tornado forms, the tornado can touch the ground and cause severe damage. Depending on atmospheric conditions, a tornado can last from a few minutes to several hours. Once the updrafts begin to weaken and the rotation of the mesocyclone decreases, the tornado begins to dissipate. In this phase, the wind speed gradually decreases and the tornado loses its power. However, even in the dissipating phase, a tornado can be dangerous. 6. Tornado detection and warning. Because of the dangers that tornadoes pose, meteorologists use a number of tools to detect and warn the public about their possible formation. Doppler radar is one of the most important tools in detecting mesocyclones and air circulation in storms. Tornado warnings are issued when significant rotation is observed in the atmosphere or when a tornado has already been confirmed by observers on the ground. This allows people to take protective measures, such as sheltering in basements or in sturdy structures. 7. Conclusion. The formation of a tornado is a complex and spectacular process involving an interaction between several atmospheric factors. Although not all storms lead to the formation of a tornado, conditions of atmospheric instability, wind shear, and high humidity can contribute to the development of an extremely dangerous phenomenon. Tornadoes remain one of nature's most powerful and destructive forces, and understanding their formation process is critical to preventing and reducing loss of life and property. This article provides an overview of the process of tornado formation, but research in the field of meteorology continues to yield new insights into how these phenomena can be predicted and studied.